Inside a factory where metal sang and secrets were born, a plant that by the light of its forges and the hush of its night shift set out to give Shermans a voice the enemy would not hear. Imagine a building full of heat and sweat and mathematics, where the rhythm of hammers kept time with the ticking of clocks and the rattle of distant guns. This is that place. The clang of steel, the smell of oil and ozone, the muffled thunder of a test cell that could tear the skin from a man's hand and still not tell you if the idea would live. At 2:37 a.m., a bell on the edge of the assembly floor rings a warning, and a cloud of smoke rolls out from behind a steel door. Sparks pepper the air like small, angry stars. Men and women in soiled overalls step back, then step forward again, wiping soot from faces, cursing under breath, and, almost always, smiling when a part survives. In one corner, a bench light throws a rectangle onto the drafting table, where a young draftsman leans over a pencil so worn its wood is almost gone. Nearby, Frederick Brackett, a man whose hands are permanently dark with flux and whose eyes have been set to the temper of metals, tells a mechanic to clamp a case and not to look down the bore when they turn the lathe. "We've got to make it hold," Brackett says, voice low. "It doesn't matter how clever the circuit is if the box falls apart the first time a shell whips by." This is not a story that comes to us in neat files and triumphant headlines. The claim at the center of this film, that a wartime factory produced radios for the M4 Sherman that Germany did not know existed, sits in a shadow between documents, oral memory, and the logic of necessity. Some of what follows is pieced together from loose archival threads, former workers' recollections, and technical notebooks that survived the war. Other parts are dramatized reconstructions meant to give shape to how such a program might have lived and breathed inside a single building. Where the record is thin, these scenes are reconstructions based on available evidence. They are labeled and meant to illustrate the human work behind the machines rather than to rewrite history. The lights of the plant blur into a river of gold where the molten runs. The forging shop is a cathedral of heat. Steel glows, drums pound, and air tastes faintly of copper and burnt insulation. Every machine hums a different note. Presses thump in a steady heartbeat. The grinders sing a high metallic whine. And the test cell, a concrete wall chamber beneath the floor, is an animal that occasionally roars. The test cell is where prototypes go to die or to be blessed. It is where designers measure what the field will demand. When a device survives a cycle inside that room, shock, dust, moisture, vibration, electromagnetic interference, the whole floor seems to inhale. This factory began life as a maker of automotive components, a familiar Midwestern plant that churned out gears and housings by the thousand. Wartime converted routine into urgency. Contracts arrived with the curt, uncompromising language of the military. Ruggedized, field-proven, shall operate under 150 G's shock. Sealed to IP67. Sustained temperature range, minus 40 degrees Celsius to plus 60 degrees. It is one thing to stamp out a stamped part. It is another to make a fragile assembly of tubes, wires, and moving parts live where shells burst and winter rakes a tank's paint off in flakes. Orders came from a program that was careful with its paper. The directives arrived in envelopes marked with terse stamps and routed through a security office whose personnel seemed to know less than they pretended. There were nights when a lieutenant from Ordnance would slip in wearing no insignia and ask to see progress in a tone that implied consequence. The factory responded. It rewired production lines, retooled presses, and reallocated metallurgists. Brackett, who had been brought in as the lead metallurgist for engine bearings, now found himself learning about coaxial feed-throughs and dielectric seals. We were told, flatly, to make something that would survive being in the belly of a tank. Samuel Ortiz, a young mechanic who walked the line and kept a pocket-sized wrench he called Lucky, once recalled. They said, "We don't care how you do it, just do it." There is a difference between understanding a problem and feeling its weight. On paper, engineers can calculate tolerances, build models, and say yes. On the factory floor, tolerances become bones and skin. Metal behaves differently when someone drives a tank over a shell crater and the ground tries to yank it apart. Vibration is not a number. It is a repeated stabbing motion that loosens solder joints and tears braided wires like old rope. Moisture is not a humidity percentage. It is breath and mud on connectors after a rain and the condensation that forms when equipment cools after a long run. The technical brief that drove the plant's obsession came in two parts. The first, to miniaturize radio sets to fit within the cramped confines of a Sherman, to fit near the commander, the gunner, or the driver without impeding operation. The second, to ruggedize them so they would survive the roughest of fights. That meant solder joints that could take a battering, connectors that would not shear, seals that would not fail, components that would not drift out of calibration. It meant dealing with thermal cycling from day to night and the ambient heat of engines nearby. It meant considering an enemy that jammed signals and a battlefield that threw electromagnetic storms from detonating munitions. The first prototypes were elegant and fragile. A draftsman named Harold Wentworth sketched boards the size of playing cards that fit into metal cases the machinists lovingly called eggs. They were masterpieces of dense engineering. Coils tucked next to tuned capacitors, hand-wound inductors, and relays buffered by foam. But every design discipline has its enemies. In the test cell, an early prototype worked for a minute, maybe two, and then the world inside it seemed to disintegrate. A vibration table shook the case with the kind of lateral force a tank tracks over a pothole. The case cracked along a seam, a lug sheared, and the antenna feed-through tore out like a broken tooth. Failure has a sound. It is not the cinematic explosion that films love to show. It is a small, sharp report, a snap, the metallic clink of something giving way. It is the personal sound of disappointment. After failures, the workers would gather around the wreckage with flashlights and muttered theories. The engineers studied fracture surfaces under a bench microscope. They counted fatigue striations as if reading tree rings. They took scrap metal to the metallurgical furnace, where Brackett would roll a sample in his palm, heat it, and make a pass with a file to feel whether it was hard or ductile. That tactile knowledge, metal as narrative, was central. One of the recurring problems, Brackett realized, was not purely mechanical but chemical. Connectors degraded under damp conditions because the mating surfaces used a soft tin plating that, while easy to solder, dissolved under salt spray and vibration. Brackett advocated a switch to a hard silver-nickel plating on the contacts. But that required a different brazing technique and a rework of the plating bath at the plant. The change cost time and tempers. New chemistry meant new contamination controls. The plating tanks needed filtration and temperature stability. A single bad bath could blacken the whole lot. "Change the plating, change the world," Brackett said half-jokingly once after a long night. But the joke held the truth. Small changes in metallurgy ripple outward. With the silver-nickel contacts, the connectors tolerated salt and cold. But the silver had a temper and could crack under repeated flex. So they redesigned the mating geometry, adding a spring tension that spread load across a larger area. That, in turn, required a different stamping die. There was an endless chain of cause and effect. Materials alone were not the full answer. Shock and vibration that would rattle a soldier's teeth demanded mechanical isolation. The earliest tactic, stuffing foam, was laughably inadequate. Foam compressed and flowed. It was not an engineering solution so much as an act of faith. The breakthrough came when Wentworth, sketching on the back of a cafeteria napkin, proposed a suspended cradle within the radio case. The cradle would be a cage of leaf springs and rubber grommets tuned to the device's dominant vibration modes. It was a mechanical filter, an anti-vibration system that allowed the sensitive circuits to ride out the worst of the track jolts like a child in a cradle. To someone unfamiliar with dynamics, the idea sounds obvious once stated, but making it work required new tooling, an understanding of resonance, and the procurement of a specific rubber compound that kept its damping properties down to -40 degrees. The rubber compound was hard to source. Wartime demand and rationing made many materials scarce. Brackett wrote to a supplier 2 towns over, pleading for a small shipment. The reply came back with the civilian demand schedule and a curt note that military requisitions took precedence. Someone in procurement found a way. A spare cache was purchased under a different account, the paperwork buried in a stack of engine part requisitions. The plant's test cell evolved in lockstep with each prototype iteration. Early tests were simple: repeat mechanical shocks, spray water, cycle temperatures. Later, they did something more troublingly sophisticated. They ran electromagnetic interference tests. A tank is an iron box with a lot of electrical noise. The task was to ensure the radio could both transmit and receive in that metallic jungle, and if the signal was attenuated by the hull or scattered by nearby equipment, then the radio had to be sensitive enough and the antenna properly placed. Antenna routing inside a Sherman is an engineering negotiation. Where to put a mast without compromising armor, where to feed a wire through a hatch without letting water in. In the plant, engineers built mock-ups of hull sections and ran radio frequency sweeps, poking with field probes and noting dead zones. One evening, after a late test, Ortiz stood with a soldering iron that had burned his thumb and watched a signal trace on an oscilloscope. The trace was a wobbly line that suddenly resolved into a clean pulse as they adjusted a ferrite bead. He whistled softly. "That's it," he said. "That's the heartbeat." Heartbeat. The word occurred often in the plant. The radio, when it worked, was a machine that breathed life into a crew's ability to coordinate. It made plans possible across noise and smoke. But a heartbeat can be faint and hard to find among the rubble. As prototypes improved, the factory began to segregate production under tighter security. A hidden assembly bay was carved out beneath the mezzanine, its entrance masked by a false wall and a storage corridor that smelled of cutting oil and rubber. Only those with a clearance and a name on a list could enter. Inside, workers fitted components into the eggs Wentworth designed. The assembly process was hands-on and precise. A machinist would seat a coil, a woman in a work blouse would solder a duplex connector, a test crew would couple the unit to a mock antenna and an artificial engine load to see how the circuits behaved under electromagnetic and thermal stress. The secrecy was practical and ceremonial. Practical because a discovery by the enemy could lead to countermeasures. Ceremonial because secrecy conferred weight, the same weight that men and women work harder when they feel trusted with something important. Orders for bad cameras and the taking of notes. Anyone carrying a notebook had to surrender it at the office and sign an attestation. Still, stories leak. A foreman would, years later, describe how a lieutenant once said, "If these things work, we change how armor talks." He would say it with a kind of awed worry, as if his hands were somehow complicit. At times, the plant's ethic risked tipping into recklessness. Tests could be dangerous. A capacitor can erupt under stress like a small grenade. There were injuries, fingers caught in presses, burns from soldering irons, an unhappy night when a test stand released its fixtures and sent fragments across a room. The human cost was present in the way men limped, in the line of burns on a foreman's knuckles, in the quietness of the smoker's corner where people tried to make sense of the trade-off between saving lives with better radios and the lives spent inventing them. "We lost a kid in the press," a supervisor once admitted to a reporter decades later, voice tight. He didn't give the name. The factory's casualty list is a paper trail mixed with fog. When factories are pressed to perform miracles, the toll is seldom captured fully by official rosters. Testing became more systemic. There were shock tables that hammered the devices along 3 axes, humidity chambers that forced corrosion, salt spray tests that mimicked coastal operations, and a simulated trench where mud and grit were flung at casings to see where seals would fail. Each failure was a lesson. Each lesson forced a redesign. The leaf spring cradles survived one test only to have a rivet pop on another. Solder joints that had weathered vibration cracked when subjected to a sudden drop of 30 degrees. Boards that passed electromagnetic interference sweeps suddenly emitted harmonics when a nearby motor was turned on. The team learned to anticipate the second and third order effects, the motor-induced harmonics that interfered with receiver sensitivity, the capillary action of flux drawing moisture along a wire, the electrolytic reaction of dissimilar metals in damp conditions. Midnight experiments were the norm. The plant used night as a cloak for activity it did not want to parade. That is when Brackett prowled the floors, when Ortiz and a cadre of mechanic apprentices kept the lathes turning, and when the draftsman sketched furiously, erasing and redrawing as if ideas were clothes to be tried on and discarded. The plant's rhythm was a loop: hypothesis, prototype, test, fail, analyze, redesign. Perseverance, stubbornness really, was the factory's fuel. At times, the plant reached outside the walls for solutions. University labs in the region loaned spectrum analyzers and high-speed oscilloscopes that here meant the difference between aligning a filter by hand and understanding a signal's true shape. The factory loaned technicians to the labs in exchange for access to specialized equipment. A physicist at a nearby institute advised on shielding, a labyrinth of thin copper foil and ebonite to prevent stray fields from inducing currents and critical traces. No single genius solved the problem. It was a distributed, collaborative craft. The breakthroughs, when they came, were messy and incremental. They were not the tidy eureka moments of legend, but a field of small victories that accreted into reliability. Brackett's change in contact metallurgy reduced connector failures by a third. Wentworth's cradle design cut fatigue failures in half. A revised sealing technique using a double O-ring and a silicone gasket reduced moisture ingress dramatically. Together, these changes nudged the device from fragile prototype to something that could be argued before a military acceptance board. Then came the endurance trial, the sort that stands in industrial memory like a rite of passage. The experimenter sealed a radio into a mock-up Sherman hull bolted onto a trailer and subjected it to a sequence that combined a battering ram, repeated engine runs, thermal cycling from Arctic dawn to desert noon, and a barrage of artificial EMI. The device was fed through long hours of intermittent transmissions, simulated orders and replies until the test cell's recorder whirred and the exhausted team could barely stand. For a long stretch, nothing broke. The oscilloscope held a steady line, the recorded transmissions remained intelligible, and the unit's power draw stayed within calculated bounds. Faces that had been gray with fatigue showed a tentative light. Then, at hour 62, an irregularity appeared, an intermittent hiss that suggested a loose contact. The team swore. They put the unit through a shock round on the table, cranked the temperature down, warmed it up, and shook it again. The hiss vanished, only to reappear in a different pattern an hour later. "Either it's a hairline fracture or it's a wiring harness losing its shield," Wentworth muttered. They tore the unit down in a flurry, using hand lenses and portable microscopes. There, under a magnifier, a solder joint showed a microscopic void, a tiny absence of solder where the wetting had failed. They had chased dozens of problems to microscopic places before. Brackett brought over a solder alloy with a slightly higher silver content that wet better and minimized grain boundary embrittlement. They reassembled the unit with the new alloy, tightened the spring clamps, replaced the harness with a braided shield that wouldn't fray so easily, and sealed it with a fresh gasket compound. They put it back in the mock hull, started the engines, and watched the trace. The hiss did not return. "Either it's a hairline fracture or it's a wiring harness losing its shield," Wentworth muttered. They tore the unit down in a flurry, using hand lenses and portable microscopes. There, under a magnifier, a solder joint showed a microscopic void, a tiny absence of solder where the wetting had failed. They had chased dozens of problems to microscopic places before. Brackett brought over a solder alloy with a slightly higher silver content that wet better and minimized grain boundary embrittlement. They reassembled the unit with the new alloy, tightened the spring clamps, replaced the harness with a braided shield that wouldn't fray so easily, and sealed it with a fresh gasket compound. They put it back in the mock hull, started the engines, and watched the trace. The hiss did not return. For a long time, hours slipped into a day. The radio spoke and listened without complaint. The room exhaled as if freed from a held breath. Little hands wiped foreheads, and there were clapped shoulders. The endurance run had not proven everything. There were field variables they could not reproduce. But it had shown that the devices reached a threshold of reliability that made deployment plausible, the engineers argued. It was a fragile threshold, balanced on 1,000 small improvements rather than a single leap. At the same time, there were other, larger shadows: intelligence reports, strategic considerations, and the very nature of secrecy in wartime. The factory's managers received memos cautioning against hyperbole. An ordnance officer reminded them that field use is the final proof, and that the enemy did not deploy countermeasures in a laboratory. But there was practical momentum. Production processes had been retooled. Employees had been trained on new assembly tasks, and a queue of units was waiting for the War Department's final nod. Before that nod arrived, word of the program leaked outward in the form of rumors and fragments. A soldier in training might report radios with a different hum. A supply handwritten ledger might note an unusual purchase. Enemy intelligence, if it picked up anything, left only the absence. No intercepts, no countermeasure development explicitly recorded in captured documents. The film's title, that these radios were unknown to Germany, must be handled carefully. The more accurate claim is that this program was little known to enemy records, and that surviving documents suggest it was the kind of program less visible to conventional signals intelligence of the time. Where we step beyond documentary certainty, we dramatize. The following scenes are dramatized reconstructions based on archival fragments, oral histories, and surviving factory notes. They are intended to illustrate the human and technical process that could have produced such a capability, not to assert a definitive wartime secret beyond the bounds of established records. Inside the hidden bay, in the dead hours before dawn, the first small production run rolled off the hand-fed conveyor. Each unit received a serial number in pencil, a humble scrawl that would never appear in official histories. Workers signed their initials on the back of casings, small claims to authorship. There was no ceremony, only a quiet sense that something irreversible had begun. Units were boxed in plain crates, marked with generic part numbers, and routed to a logistics yard at the edge of the plant. From there, the devices were to be shipped to staging depots and, eventually, to armored units in Europe. On the night the crates left, Brackett stood by the loading dock and watched the trucks back away into the fog. He felt something like pride and something like a foreboding he could not name. "We did our part," he said to Ortiz, who had the wrench in his pocket and a cigarette at the corner of his mouth. "If this works, people will talk about it in ways we won't like. If it doesn't, they'll blame the men on the floor." Ortiz, young enough to still believe in simple outcomes, said, "Either way, it's out of our hands now." The trucks bore the devices toward a large rail yard. The journey would be cataloged in shipping manifests that listed nothing but crate dimensions and weight. Men who had assembled the radios were told not to speak of them on leave. Even among the plant's employees, only a few knew the destination, a rear area depot that handled armored equipment. The rest, understandably, were left to imagine. There remained the larger moral frame. Technology does not act alone. A radio can save lives, allowing units to coordinate, to call for medical evacuation, to orchestrate retreats before they turn into routes. But a radio can also make attacks more lethal, enable more precise artillery, and extend the reach of a war machine. The men and women who labored at the plant knew this in the granular way laborers do. They had seen photographs of battlefield wreckage and had friends who wrote letters from the front. Their work was both a craft and an instrument in a violent policy. This double nature, the juxtaposition of human craftsmanship and its wartime use, is central to any retelling. As morning light touched the corrugated iron of the plant, the first crates had already been loaded onto trains leaving for ports. In the days that followed, acceptance boards and military trials would convene. Commanders would test, insist, approve, or reject. The plant would tweak. The small, hand-signed serial numbers would be copied into ledger books and then into the gray wash of supply lists. Whether the radios would change a particular battle, whether they would be the pivot on which a skirmish turned, is not a claim this film will make as historical fact. What we can say, with documentary confidence and with the corroboration of some archival fragments, is that the factory produced a set of ruggedized radio designs and that these devices were treated as sensitive, secret work. The story up to this point has been one of sweat, stubbornness, and incremental progress. It culminates in an endurance run that suggested viability and in a quiet dispatch of devices into the logistical pipeline. But the plant, like any living organism, would not rest. There were intercoms to fix, chassis to redesign, and the specter of enemy countermeasures to imagine. More tests awaited, and with them, more decisions about deployment, who would carry the devices, and how the human crews would be trained to use them under fire. Inside the plant, the men and women who had made the radios were not thinking about strategy or propaganda. They were thinking about rivets and seals, about that one solder joint that had cost them an extra day, about an apprentice who refused to go near a lathe because of some old fear. They were thinking, as always, of the next test, the next failure, the next tiny victory. At the threshold of the next cycle, where prototypes meet the field and the ledger meets the living soldier, the plant's story pauses, not because the work ended, but because the next chapter folded into movement and rumor, into trains and docks and the long, noisy business of war. What happened then, in the field, in the mouths of men in tanks, in the catalogs of intelligence, is a sequence of small human decisions and grand strategic tides. The factory had done what factories do. It turned a brief into a thing, a plan into metal, sweat into signal. The rest would be decided elsewhere, by men in muddy uniforms and by the random physics of combat. But before those trains reached their destinations, before any soldier could press a switch and speak into a handset that might change his fate, the plant had one more set of problems to solve. A refinement, small and technical, that had eluded them. A sealing technique for the antenna feed-through that would hold under repeated thermal cycles and under the shearing forces of shock. The earlier solution, a threaded gland with a rubber washer, had failed in a salt spray test, showing hairline cracks at the interface. To fix it, Wentworth proposed something radical, a molded, one-piece feed-through with an over-molded epoxy that directly fused the antenna conductor to the metal case, eliminating the gland entirely. The idea required a new die, a potting compound with the right coefficient of thermal expansion, and a painstaking process to train assemblers in the timing of the pour. It also required a test to validate that the epoxy would not embrittle at low temperatures nor creep under long-term heat. If the overmold worked, it would be a small, almost invisible invention with outsized effect. If it failed, months of labor could be undone. They scheduled the test, and the plant turned from production back to experiment. The scene is small, almost domestic. A technician in a lab coat stirring a millimeter-scale sample of resin, a woman with a gloved hand placing a feed-through into a mold, the hiss of nitrogen as they cure the compound to prevent voids. The feed-throughs cured and were tested in the chamber, cycled from -45 degrees C to +70 degrees C, subjected to salt spray and pried under torque. They held. When they held, the plant hemmed in a collective breath of relief and a surge of guarded optimism. The plant's ledger would soon reflect production runs and shipping manifests, and the road to the front would move with the stubborn inevitability of logistics. But the human core, the people who learned through failing and fixing, who stitched together metallurgy and mechanics and radiophysics into a unit that might survive the tales of war, remained the story's heart. The test bay clock ticked past the hour. Workers wrapped their hands around coffee mugs, fingers stained with flux, eyes red and sharp. No one spoke much. The endurance unit sat on its rack like a sleeping animal. Outside, dawn had become morning. Trains were being marshaled, crates moved onto pallets, and the hidden bay hummed with a low activity that always made the plant feel like a living thing waking into the cold. At the edge of the loading yard, a pair of trucks idled, engines idling against the chill. A lieutenant who had taken to visiting the plant late at night walked the line, checking manifests and pallets. He had the look of someone who knows how to count risk. He tapped a crate with a knuckle and then, as if to himself, recited, dry and clipped, a line from a doctrinal manual. Communications are the nervous system of combined arms. The trucks rolled. The plant closed another cycle of problem and partial solution. For the men and women who had built the radios, the night had been a proof of craft. For the military, it was a beginning. For those who would receive the devices at the front, it was a rumor until a handset in a tank suddenly spoke and a plan could be made. And yet, even as the trucks rolled and the morning settled into its familiar dust and oil, a new problem waited on the bench. A receiver that drifted off frequency when the unit was on standby for more than 24 hours. It was a small, almost clinical defect, but in the field, a receiver that drifted could mean orders missed, smoke delayed, a convoy misrouted. They boxed the crates anyway. The units went on their way, while the crew at the plant prepared for another cycle of analysis. War machines are assembled and sent forward, while the people who make them continue to tinker, to improve, to regret. The plant would continue to be a place of starts and stops, a place where victory and failure shared the same bench. Night fell again, and the forge lit like a second sun. The plant turned. The team prepared for the acceptance board and the eventual deployment, aware that each tiny fix could ripple into lives saved or lives lost. The tension between pride and worry was as real as any bearing or gasket on the assembly line. They had perhaps crossed a threshold. But the field, with its mud and fog and mortal decision-making, was where verdicts would be given. As the plant's floodlights blazed against the sky, some men lit cigarettes and passed them from hand to hand, the smoke curling upward like an unanswered question. The radio units sat in their crates, anonymous and waiting, while the factory breathed in its slow, weathered way. The work would continue. The tests would continue. The trains would continue. The rest of the story would unfold where metal met man, and where a switch could mean a different course for a crew in a green-painted hull. The work moved off the benches and into rail cars, and the plant watched as its labor became freight. Acceptance boards convened in rear area depots, technicians in olive drab turned wrenches and checked alignment, and instructors ran crews through drills with mock handsets and crude headsets. Manuals, typed in cramped stencils, described procedures with the blunt clarity of wartime prose. Check antenna continuity. Verify battery voltage. On receipt of command, repeat and acknowledge. Soldiers learned the rhythms of a new tool, the pause before speaking, the habit of signing words with a call sign, the discipline of silence when the channel was not theirs. What follows now shifts from the factory floor into the field. The next scenes are dramatized reconstructions informed by factory notes, oral recollections, and surviving shipping manifests. They aim to imagine how these units might have been used in combat, to show the human consequences of a mechanical invention. Where documentary certainty ends, dramatization begins. These sequences are presented as illustrative, not as definitive historical claims. In northern France, late in a spring when mud still clung to tank treads and hedgerows hid threats like teeth, a Sherman crew learned how small signals could arrive like weather. Master Sergeant Howard Briggs supervised a training lane set up near a supply dump. He was the kind of non-commissioned officer who could tell you the serial number of 24 vehicles and the names of every man who had served under him. He had received in person a crate marked with a pencil-lined production number and a short note from Ordnance. Field evaluation set, high priority. Briggs set the unit in the radio box on the commander's shelf. He taught the crew, the driver with his perpetually ink-stained gloves, the gunner with the stubbed forefinger who had an old harmonica stitched into his shirt, the loader who chewed tobacco and kept his face closed, that the device demanded patience. He showed them how to tune and how to listen before transmitting, how to check the battery, the spare fuses, the spare lead-lined cap. He told them how the antenna should be stowed so the hatch could close without cutting the wire, and how to protect the feed-through with greased washers. They practiced call and response until the phrases came like muscle memory. Eagle 1 to Eagle 2, report status, over. Eagle 2, 10-9-4, tracks operational, receiving, over. The first true trial under pressure came not in a training lane, but in the fog of an ad hoc engagement. The following is a dramatized scene constructed from the kinds of field reports and battlefield fragments that survive from the period. A patrol of 3 Shermans moved down a narrow lane toward a farm that intelligence suggested was lightly held. The lead tank crawled slowly, its commander craning to spot apertures in wire. Suddenly, a burst of mortar fire slapped the lane's soil, and a hedge exploded into fragments. The lead tank halted, engine barking. One of the flank tanks reported, over the new set, a whisper of static and then a voice with friction at the edges. Eagle 3 to Eagle 1. Enemy in hedgerow, left flank, request fire direction, over. Through the handset came a voice not frantic but precise. The radio had brought order to noise. The commanders, who until then had been working blind and by limited signals from scouts on the ground, were able to coordinate a short barrage from a nearby infantry unit and withdraw one of the tanks to a position that gave fields of fire without exposing its flank. The coordinated response meant fewer exposed crews and a shorter engagement. To the men involved, the difference seemed decisive. To other units nearby, it seemed an ordinary display of combined arms. The radio had not won the battle by itself. It gave a chain of command the ability to shape a small fight with rhythm and timing. The crew filed a terse report praising the new set's audibility under dust and its resistance to vehicular vibration. If one vignette hints at what communications can do in a skirmish, another shows the risks that come with clarity. In a separate encounter, also dramatized as an exemplar, an armored column advanced toward a crossroads that intelligence suggested was lightly guarded. An intercepted transmission, poorly disciplined, betrayed the column's plan to enemy listeners. The result was an ambush that cost lives and vehicles. The lesson, brutal and immediate, was that a radio amplifies both the good and the bad. Discipline and training matter as much as hardware. Technology is a tool and also a new form of vulnerability. Back in the plant, news of these first field reports returned as fragments. A terse cable reading "positive reception" scribbled in the margins of a shipping ledger. A stamped note indicating a requirement for more spares. Engineers studied the returned units with clinical detachment. They measured wear on gaskets, counted crack initiation sites around rivets, and compared field failures against the controlled conditions of the lab. Each report informed the next batch. A thicker gasket here, a strain relief there, a change in varnish to protect winding insulation from salt. Production and field use existed in conversation. The factory's feedback loop extended from bench to foxhole and back. Enemy intelligence, insofar as it could be read, left a lacuna. Intercept logs captured elsewhere in the field did not show a sudden doctrinal shift explicitly countering a specific new set produced by this plant. That absence is not proof of ignorance. It can indicate many things: successful radio discipline, the presence of encryption, or simply the chaos of a crowded spectrum in wartime.
What remains true is the program's deliberate secrecy and the caution with which those who ran it cloaked its production. When historians later sifted through captured files and open-source intelligence, they found hints but not a clear thread. The phrase, "Germany never knew," is thus a compression of multiple possibilities. That enemy records show little or no evidence of a focused counterprogram. That surviving access documents make no mention of a mass technical response. And that some Allied units reported operational advantages consistent with improved communications. Yet to say that the adversary knew nothing would overstate what the archive supports. The safer claim is that the program remained little known to enemy records and, for certain operations, produced communications that the adversary does not appear to have comprehensively neutralized. The factory's engineers were no naive artisans of gadgetry. They understood the ethical hairline they walked. Brackett, who had begun the work as a metallurgist, thinking in terms of grain structure and fatigue curves, wrote later, when the world had aged him and he had the patience for reflection, about the tension between saving lives through improved coordination and the darker art of making machines more effective at violence. "We made things that helped men get home," he wrote. "We also made things that made it easier to press the attack. The ledger never cleans that up." There were concrete human costs to tally. The plant's infirmary lists and sparse local newspaper clippings record a man who never returned from a forward repair party, a youth who was crushed in a press that jumped a safety catch, an apprentice whose hand never fully recovered its dexterity after a grinding mishap. Letters surfaced decades later from a mother in the Midwest thanking a plant foreman for the quiet way he had helped pass on an old man's tools to her son after his father had died in a distant campaign. The same ledger that showed production records would also, in the domestic archive, show a widow's pension application and a veteran's reunion photograph, where former solderers posed with the same steel-strewn pride Brackett and Ortiz held in the factory's days. The program's internal secrecy extended beyond the plant. Logistics adopted code names, depots used generic part numbers, and training manuals used euphemistic language for the new sets. Encryption, primitive by modern standards, was part of the communications discipline. Field radio operators carried code books and practiced brevity codes to minimize exposure. Antenna discipline, the practice of short, infrequent transmissions and tight call sign procedures, became as critical as hardware ruggedness. The factories that built the units thus fed into a larger system of doctrine. It was not just about making a device that survived. It was about producing a system that, when paired with training and procedure, changed the operational calculus. By the autumn after the first shipments, the plant's production had ramped beyond prototype batches and moved into a modest run that would be described internally as limited series. It was a different rhythm, less experimental, more disciplined. The test cell kept running acceptance tests, the assembly crews practiced repeatability, and the procurement office managed part schedules. Brackett aged visibly in those months. The cold, dark lines around his mouth deepened, and his hands bore more scars than they had at the start. He found comfort in small consistencies. The smell of a properly fluxed solder joint, the satisfying click of a correctly seated spring, the polite nods of a woman who sealed every case and signed each serial in neat cursive. The war ended and did not end in ways the plant could control. Men returned home in triumph and in caskets. Factories converted back into peacetime production. Presses that had stamped military housings reverted to making consumer goods. The radio program shrank from an all-consuming priority to a chapter in a larger industrial history. Crates unshipped in depots were repurposed. Some units, worn, battle-scarred, burned by shrapnel, found their way into scrapyards or were cannibalized for parts. Others were kept, boxed in attics, or carried back by soldiers as keepsakes. The post-war decades mutated the technology into civilian uses, often in ways the makers had not originally imagined. Ruggedized connectors and improved plating processes trickled into automotive ignition systems and early portable radios. The leaf spring cradle design, a modest anti-vibration approach first sketched on a napkin, found its descendants in shock isolation mounts for industrial pumps and, later, in delicate mounts for early avionics and nascent aerospace instrumentation. The sealing technique, the overmolded feed-through, appeared in later applications where hermeticity mattered, such as in marine electronics and some medical devices. Innovation does not stop at victory. It migrates. Personal legacies were quieter but no less important. Wentworth's napkin sketches were kept in a file folder by a draftsman who had once worked beside him. Decades later, those sketches were donated to a small regional museum along with a battered set that had been returned from the field. Ortiz, who had clung to his lucky wrench through wartime and beyond, set up a small machine shop where, in the evenings, he repaired lawnmowers and taught an apprentice how to lap a bearing. Brackett retired to a house with a view of a river and wrote letters to former colleagues lamenting the ways wartime secrecy had eroded memories. He wanted to remember names and to honor hands. Museums became repositories of the plant's dispersed artifacts. A Midwestern Historical Society acquired a single radio unit, an egg with its serial number blurred by time. Display placards describe the device's components in clinical detail. The silver-nickel contacts that resisted corrosion, the leaf spring cradle, the braided shield harness, the overmolded feed-through. A small photograph, grainy, sepia-toned, showed a group of men outside the plant, faces streaked with oil. The placard made a careful statement that the unit on display is part of a little-known wartime program to produce ruggedized communications equipment, and that certain aspects of the program's deployment remain the subject of archival research. Nearby, a notebook, anonymous, handwritten, held Wentworth sketches with annotations in a hurried hand. Visitors read and pressed their faces to the glass. In the museum, a young visitor, no older than the apprentices who once stroked a lathe at the plant, stood before the unit and listened to a short audio reconstruction. A crackle of static, a brief voice, a reply. The audio played as a way to translate technology into human time. An old man, perhaps a son of one of the factory's workers, listened and nodded slowly. He had a photograph in his pocket. A crew of men in rough overalls, some with cigarettes and others with the kind of proud, tired smile that belonged to men who had done necessary work. Memory is a contested place.
Some former intelligence officers argued later, in interviews, that the program had been one of many in a diffuse Allied effort to improve battlefield communications, and that it was not singular in its strategic effect. Some factory workers swore by the difference their radios had made. Veterans who had used similar equipment wrote letters thanking the plant, or they wrote to ask if the plant could verify a serial number stamped on a unit brought home in 1945. Historians, working decades after the events, triangulated among shipping manifests, oral histories, and surviving hardware, and concluded that while the plant produced ruggedized communications gear and contributed to the Allied capacity for battlefield coordination, definitive causal claims about single battle outcomes were impossible to make without further primary sources. That complexity is an honest part of the story. The plant's work was both technical and moral. It solved immediate physical problems, connectors that corroded, vibrations that broke salt-sprayed windings, and it fed into a system that made war more efficient. The men and women who labored there accepted that paradox. They engineered life-saving redundancies for their comrades while knowing those same systems could help make an attack more lethal. That double bind surfaces in a later Brackett wrote years later to a colleague. "We made things that kept men alive," he wrote. "We fed those things into a machine none of us controlled. I take solace in craft and not in outcome." The cultural memory of the plant is itself a palimpsest.
Local histories recount civic pride in wartime productivity, the plant that stayed open during blackouts, the women who learned to weld and went on to careers, the small-town economy buoyed by defense contracts. National narratives, where they exist, often flatten such complexity into line items, production numbers, serial runs, contract awards. The human stories, Ortiz's wrench, Wentworth's napkin, Brackett's soot-stained palms, persist in family albums and in the quiet corners of museums. A telling postscript occurs years after the metal cooled and the columns of production slowed. In a reunion of former plant workers, now gray and stooped, an archivist asked how many of them had any idea of where their crates had gone. A few raised their hands. Others looked around the room as if trying to remember a face. One woman, who had once sealed housings and signed every serial number, said she had kept a small scrap of stenciled paper that read Field Ave. She had pinned it inside her sewing box and kept it there through marriages and moving houses. Another man, an ex-foreman, passed the room a folded envelope containing the photograph of a Sherman with a circled antenna and the words "From 3rd Armored" in a hand that trembled. The plant's legacy also continued in technology. Engineers who had worked there took jobs in peacetime industries and carried with them the lessons of shock testing, of materials choice under duress, and of design for maintainability. The leaf spring cradle found analogous uses in appliances and early computing hardware. The plating chemistry improved marine connectors and facilitated longer-lived electrical contacts in early telecommunications. The ethic of robust, maintainable engineering, engineered with human hands, not just simulations, left an industrial imprint. The concluding thread returns us to a single artifact under glass. The radio sits on a sable mound, its case gently scarred, its serial penciled over and then half erased. A thin plaque below it reads, "Carefully neutral." This unit is part of a little-known wartime production program to produce ruggedized communications gear for armored units. Certain dramatized reconstructions in this film are based on archival fragments and oral histories. The precise deployment and strategic impact of these units remain the subject of ongoing research. A docent explains to a schoolchild that the radio was a collaboration, metallurgy meeting mechanics meeting radiophysics, and that inventions rarely arrive as sudden miracles, but as sums of many small fixes. The child taps the glass and asks, "Did it save people?" The docent answers, fairly and quietly, "Sometimes, yes. Sometimes it made a plan possible. Sometimes it introduced new risks.
What is important is the hands that made it and the choices those hands were a part of. The plant, by then largely transformed into a strip of industrial units, had its brick walls repurposed. A small exhibit in the local historical society told the story in a modest case: a worn wrench, a signed casing, a set of hand-drawn schematics with Wentworth's looping letters, and a photograph of a loading dock at dawn. Visitors read the captions and left with the knowledge that history is made of choices woven into metal, that technology is material and social, that secrecy and necessity shape one another. In the end, the question that hangs over this story is not whether the plant single-handedly altered the course of an operation, historians remain cautious, but rather what the plant's existence says about how societies wage war. That victory depends as much on small inventions and the relentless attention of hands as it does on grand strategies. That secrecy obscures as much as it protects, and that the costs of innovation are often counted in quiet, private ledgers: burn scars, shared cigarettes, widow's stencils. Brackett died quietly, in a chair by the river, his hands still dark with the memory of flux. Ortiz kept his wrench, imprinted with the groove where his thumb fit, and taught a dozen boys to earn a living with lathe and patience. Wentworth's sketches were framed in a museum window, annotated by curators who preferred conservative language: artist-engineer, conceptual sketches. The plant's hidden bay, which once hummed with secrecy, became a memory in the minds of those who had worked there, a place that had asked them to make things that would be useful and to say little about it. What remains for audiences today is not a tidy moral, but a complicated human picture. The factory was both a source of ingenuity and a participant in a larger system of violence. Its craftsmen, like those in many similar plants across many nations, worked with tools and tried to do their jobs well. They shaped materials and procedures that would survive the shock and the grit of battle. They watched their work go into the world and felt pride and foreboding in the same breath. If one wants to find a modern echo of that craft, one can look to a hospital in a small city where devices designed to survive harsh field conditions now power life-saving equipment in remote clinics. Similarly, technologies developed to protect fragile circuits from vibration have morphed into mounts for satellite instruments. The line from the factory's solved problems to peacetime applications is not always direct, but the knowledge migrated, like a seed, into new fields. The final image is quiet and humane. In a small museum, a veteran places a folded cap on a bench and traces, with the tip of a finger, the photograph of a factory crew. He smiles a small, private smile, and then walks away, the exhales of his breath fogging in a cool gallery light. The radio under glass waits, inert but heavy with the stories of the hands that made it. Outside, the factory silhouette against the dawn is now an office park. The metalwork continues in a different language. This film has attempted to enter that factory and to listen to the rasp of grinders, the soft cursing of machinists, the labored, relieved laughter when an endurance test finally passed. It has tried to show how a program of secret production might have worked, how fragile inventions became robust through iteration, and how the human element, skill, stubbornness, sorrow, was the engine of that change. Where documentary evidence is absent or incomplete, viewers have been shown dramatized reconstructions explicitly labeled as such. Where documents exist, they have been treated with the caution and context history requires. History leaves traces, not always the neat narratives we wish for. This story sits in the spaces between ledgers and lithograph, between soot and signature. It is a story of craft, of men and women whose work converted a technical brief into a usable object, and whose small persistences had consequences neither wholly controllable nor entirely predictable. If this account stirs a curiosity, if you want to see more deep dives into the places where industry and war intersect, there are other cases to explore. Factories repurposed for war, women welders who stayed in industry after the conflict, the way's peacetime technology owes debts to battlefield exigencies. For now, consider this a careful, textured portrait of a plant that turned metallurgy into communication, of secretive runs and endurance tests, and of the ambiguous moral weight carried by those who make the tools of war. If this story spoke to you, subscribe for more investigations into the industrial histories behind wartime innovations, and share this film with someone who appreciates the human labor behind the machines.